A robot that can think with its fingertips. Yeah, this changes everything. Physical intelligence just dropped something wild called Pi 0.5, and it flips the whole idea of robot brains on its head. Instead of one big brain sitting in a central hub, this system spreads mini brains all over the body, one in each fingertip, elbow, even inside soft silicone skin. These microbrains can sense, decide, and adapt instantly, right where the action is. So what happens when you give a robot this kind of localized smarts? You get a machine that walks into a messy apartment, figures out where the dishes usually pile up, and just starts cleaning. No Wi-Fi, no central processing lag. It's not acting like a command-following drone. It's more like a team of lightning-fast reflexes working together in real time. That's the kind of intelligence robots need if they're going to leave the lab and function in real homes. Here's where it gets even cooler. Pi 0.5 actually has 2 layers of intelligence. The bottom layer is all about reflexes. Traditional bots send every sensor signal back to one bulky processor. That's fine for repetitive factory tasks, but toss that bot into a chaotic living room? It's a hot mess. Pi 0.5 uses distributed Pi nodes, like smart Lego blocks, spread throughout the robot. Each node has its own sensors, its own motor hookups, and its own tiny neural network that constantly asks itself, did that grip improve? Did that reduce tension? Then it adjusts on the fly. No need to ask the mothership for permission. This setup cuts down on power usage and boosts performance. In tests, a soft robotic gripper using these reflex nodes had a 30% better grip and used 25% less energy. Same results for a haptic sleeve, better feel, longer battery, no hand cramps. These nodes even predict stretch and strain before a camera would notice slippage. Now for the brainy upper layer, also called Pi 0.5. This part acts like a vision language action model. Basically, it learns by watching a ton of robot footage, 400 hours of bots navigating real homes, bumping into furniture, lifting pans, opening drawers. It's also trained on web images, captioned videos, object labels, and even humans talking the robot through chores step by step. So instead of freezing up in a new environment, this AI knows how to adapt. It knows what a pillow is, how to treat a glass plate, and when to be gentle or firm. In test homes similar to training environments, it followed voice instructions with 86% accuracy and completed tasks with 83% success. And when tested in completely unfamiliar homes, it still crushed it. 94% success. That's huge. And here's the kicker. When they removed variety from the training data, performance plummeted. No web photos, accuracy drops to the 70s. No multi-home robot clips, it tanks to 31%. So yeah, data diversity is the fuel this thing runs on. Another insane detail, Pi 0.5 literally thinks in steps. Every second, it generates a sentence like, pick up the spoon. Then, it switches gears and generates 50 precise joint angles to make the arm move. The local reflex nodes handle fine grip control, while the high-level brain plans the next move. It's like your spinal cord holding a coffee cup while your brain wonders what you were doing. They tested all this in random apartments, no pre-maps, no markers. The robot made beds, folded laundry, cleaned up spills, even scooped toys. And if someone bumped its arm mid-clean, it recalculated and kept scrubbing. You can give it direct orders like pick up the round brush or open-ended ones like clean the bedroom, and it'll break it all down and handle it. Power-wise, it's a beast. Each node only activates what's needed, so mobile bots last longer between charges. And these things run on tiny microcontrollers. You could power one off a coin cell battery. Total edge intelligence. Oh, and the math is slick too. Normally, generating a movement path takes dozens of steps. But using something called flow matching, Pi 0.5 creates an entire 1-second action plan in just one pass, perfect for real-time reactions. The team behind Pi 0.5 knows it's not perfect. Sometimes it grabs the wrong thing or takes a weird path. Their dream? Models that learn from their own experience, ask questions when they're unsure, and can switch between robot bodies, like jumping from a floor bot to a wearable sleeve without retraining. They're also looking for partners. Think grocery stores, hospitals, elder care homes, anywhere messy enough to give these bots more training data. At the end of the day, what makes Pi point 5 special is its two-part brain, fast, flexible reflexes embedded in the body, paired with a world-wise AI trained on real homes and real conversations. It doesn't just follow instructions, it thinks with its sensors, learns from its world, and adjusts in milliseconds. So here's the question. What would you have a Pi point 5 robot do first in your home? Drop your answer in the comments. Smash that like button if this tech blew your mind. And subscribe if you want more deep dives into the wild world of AI and robotics. I'll see you in the next one.